In this video, we will discuss about current density. It is linked to current electricity chapter, and in this chapter we already studied Ohm's law and electric current. We know what is the Ohm's law. Potential difference across the element is directly proportional to current flow into the elements. If dropage across the element is V, dropage across element is V, and current I is flowing in that element, then V is directly proportional to I is what? Ohm's law. Once we remove this one, we are getting a proportionality constant, and that is R. Clear? I. So we can say R equal to V upon I. This is Ohm's law. We also studied in another way, we can say current density is directly proportional to electric field intensity. And once we remove this, what we are getting? Conductivity into electric field intensity. So this is also a Ohm's law. We studied this one also. So in this class we will discuss what? Current density. What is our task? We are discussing each and every physical quantities which we use in the Ohm's law. So in the last class we studied what? R equal to V upon I, and it is what? Constant. So in the last class we studied about the current or electric current. Now in this class I am taking this point, current density. So current is what? I am just revising. What is the current? Current is flow of charges. Clear? Current is what? Flow of charges, and it is charge per unit time. Current is what? It is denoted by I equal to Q upon T, charge per unit time. Now I am taking J, current density. So what is the current density? Current density is current passing per unit area. What is the current density? Current density is current passing per unit area. I am having this area. It is A. Its area is A, and current I is passing. Charges is flowing in this area. Charges is flowing perpendicular to this area, normal to this area, and this is A area. Its cross section area is A. Current I is flowing in this area. Then current passing per unit area. Current passing per unit area means current upon area will be what? Current density. Again, what is the current density? It is current passing per unit area. So this is the one area, and in which I current is flowing, then its current density will be what? I current passing per unit area, current upon area. Clear? And its unit, in which J is what? Current density. Current density is denoted by J, and current is what? I, and A is what? What? Cross sectional area. A is what? Cross sectional area of object or surface, we can say. Now what will be its unit? The SI unit of current density is, we are having current upon area. What is the unit of current? Current is ampere. What is the unit of current? Ampere. Ampere is denoted by capital A, or we can say AMP. Both are correct. So ampere upon, what is the unit of area? What is the area? Area of a field will be what? Length into breadth. What is the area? Area is, what is the unit of the area? Area is length into breadth. Area equal to length into breadth. length having unit meter, breadth having meter, so we can say meter square or centimeter square. In MKS we are having meter square, and in the CGS we are having centimeter square. So we can say current density is current passing per unit area, and its unit is ampere upon meter square, ampere per meter square. In MKS, in the 11th standard we studied what different types of the systems of the units. We are having three types of the systems: MKS, CGS and FPS. And internationally we are following what? SI. SI is what? International System of the Units. Clear? So in the MKS we are having ampere upon meter square, and in the CGS we are having ampere upon centimeter square. Clear? And what will be its dimensional formula? Its dimensional formula, from this formula we can say current is base quantity, it is a fundamental quantity, its dimension is A, and area having dimension length into breadth. Length and breadth both are showing what? Length. So L1 into L1, L into L. So we can say L square. So from denominator to numerator when we convert, then this will be negative. So L minus 2 A1. L minus 2 A1. So in MLT we can say M0 L minus 2 T0 A1 will be what? Dimensional formula of current density. We should know the dimensional formula in units of all physical quantities. It is okay, it is in the 11th standard, but in the competition, these types of the questions asked from any physical quantity. They may ask any physical quantities. So you should know the dimensional formula in unit of all physical quantities. So its dimensional formula is this one. Now current density is current passing per unit area, and it is what? Vector quantity. Observe, it is vector quantity. Current is a scalar quantity. Current is having both direction and magnitude, but it is not a vector. It is a scalar quantity because it does not follow the addition rules of vectors. Clear? Now, but current density is what? Vector quantity. Or vector quantity, how we will represent? In the vector quantity we will put what? Arrow marks. Arrow marks. Put what? Arrow marks. So current density will be what? We can put arrow marks on J like this. How? It is a vector quantity, so we can put arrow. This arrow is showing current density is what? Vector quantity. Clear? Now next one, it is a vector, so vector quantities are having both magnitude and direction. Vector quantities are having both magnitude and direction. So direction is its direction. Current density direction is the same as the direction of the current. Same as the direction of the current. How? Observe. In the last class we studied direction of the current. Again I am drawing there. This is a one conductor, and I am applying one source there, plus minus V. This is the cell. We know, or this is what? This is the circuit. A circuit is what? Closed path. In the circuit, current starts from positive terminal of battery to negative terminal of battery. Yes or no? In the circuit, current starts from positive terminal of battery to negative terminal of battery. And in the conductor we are having electrons, and flow of electrons will be what? Opposite of this current. Opposite of current direction. So if current is flowing from A to B, then electron flow will be what? B to A. And this flow, current direction flow will be what? Current density. Its direction is the same as the direction of the current. Current density direction will be same as a direction of current. And direction of current is what? Direction of motion of positive charges. What is the current? Current is the flow of charges. It means this is the current direction. It means flow of the charges, and flow of the charges is what? direction of motion of positively charged. This current starts from positive terminal, so it is the flow of positive charges. We can say it is a flow of charges, it is a flow of current, or we can say it is flow of positive charges. So we can say current direction is flow of charges, flow of positive charges, and it is the direction of electric field. What? Current direction is what? Electric field direction. Flow of charges direction. It is a flow of positive charges direction, and same as a current density. So what we are observing? Its direction is the same, and current density direction is same as the direction of current, and current direction is what? Electric field direction. Electric field, it is the direction of electric field. Current direction, in this direction electric field is flowing. Electric field direction. And direction of motion of positive charges. Obviously current starts from positive terminal of a cell, so this will be what? Flow of positive charges. We can say what? Flow of positive charges. So finally we can say current density direction is same as current direction. Clear? Where? In a object, in a surface area. Clear? When we consider this conductor and its cross sectional area is A, then current direction will be current density direction. Clear? Now, so till what we studied? Basic of the current density. Again I am revising. Current density is current passing per unit area. If we are having a cross sectional area, if we are having surface and its cross sectional area is A, and current I is flowing that particular area, then we can say current passing per unit area, current to area ratio will be what? Current density. It is vector quantity, and vector, it is vector, so its direction will be same as a current direction. Clear? And its dimension formula is this one, L minus 2A1. Clear? And now similarly in current, electric current, we studied normal current, then average electric current, and finally instantaneous current. So in this also we are having, this is the normal current density. But when we talk about the average current density, then what? Before this one I am taking this one. Current density is directly proportional to electric field intensity. We already studied in the Ohm's law, current density, Ohm's law is what? At constant temperature, current density is directly proportional to electric field intensity. How? We verified that one is also. So we can say current density is directly proportional to electric field intensity. Why? Observe this one. In this point what we studied? Its direction, current density direction is the same as the direction of the current and electric field. It means current density direction is electric field direction. So both will be what? Proportional. Are you getting what I am saying? Current density direction is current, electric field, or motion of positively charges. So we can say current density will be directly proportional to electric field intensity. When we remove this proportionality, we are getting a coefficient that is called sigma, and it is what? Conductivity. And conductivity denoted by sigma, and it is a reciprocal of resistivity. Rho is what? Resistivity. Clear? We will discuss separately resistivity and conductivity. Don't worry about these topics. We will study in deeply. And E is what? Electric field intensity or electric field, this one. Clear? Now average current density. Average current density is what? If delta I current is passing in the area delta A, then average current density is what? Delta I to delta A. What is happening? This is surface and its area is what? Small area I am taking delta I. Its surface, its small area is delta A, and in which delta Q charge flowing. Delta Q charge is flowing, it means current will be what? charge per unit time will be what? Current. So delta Q charge is flowing. It means delta I current will be flowing. So we can say delta I upon delta A will be what? Average current density. So what? If delta I current is passing in the area delta A, then average current density will be what? J average, AVG average equal to, and it is the vector quantity, so we are using arrow on J, delta I upon delta A. Now we want instantaneous current density. So how we will find this one? What is the instantaneous? The current density at a point. The current at the instant or time t, what we obtain? Instantaneous electric current. But current density at the point we are having field or surface at a particular point we want current density, then how we will find? We will use limit delta A tends to 0 of average current density. Average current density limited at delta A tends to 0 at the surface area. Clear? Then J equal to limit delta A tends to 0, J average, and J average is what? Average current density. We will put this value there. When we solve, then we are getting this delta is converted into what? Di by dA. It means what? Di is what? Change in current upon area, change in area. What area is changing? If two area we are having and currents we are having, then we can use this one. So current density equal to Di upon dA. Clear? So J equal to Di upon dA will be instantaneous current density. Clear? Now if the cross sectional area is not normal, if the cross sectional area is not normal, it means not perpendicular to the current, in which this cross sectional area is perpendicular to this current. On this surface current direction is perpendicular, but current is not perpendicular to this surface, then what will be happen? If the cross sectional area is not normal, like this, normally we are having this surface, but once we move this surface at angle theta, not normal, it means not normal means not perpendicular. This surface is perpendicular to this current, but in which we are moving this surface at angle theta, and current direction is not perpendicular, current direction is not perpendicular to this surface, then what will be happen? It means this surface, this surface area, once we, so not normal to the current but makes an angle theta. What angle theta? The direction of the current, not normal, but this area making the angle theta with the current. Current is what? Current is current or current density, both direction is same, so it is making angle theta with this surface, making the, it is the its center point perpendicular line, and it is making with theta angle with current direction. Clear? Then when its area is dA, small area is dA, once we take its component, we are getting its two component. With theta we are getting cos theta component, and its perpendicular component will be what? Sin theta. So with theta or in the direction of the current, what component we are getting? This one. So what we can say? J equal to Di by dA cos theta. Observe, when we use this one, if a cross sectional area is not normal, if cross sectional area, that time this surface is, this area is having, in this area current is passing what? Perpendicularly. Area current is passing perpendicularly, but this surface area, this area is moved to theta angle this surface area is moved to theta angle, or we can say current with this surface area making an angle theta. Observe, if the cross sectional area is not normal, it is not normal to the current, that time it is normal to the current, but once we make an angle theta with the direction of current, this is direction of current, we are making angle theta and we are moving. How we are making angle theta? We are moving this surface at theta angle with current. Then when we moved this to theta, then we are getting this surface area. So not normal, current area is not normal to current, but makes an angle theta, makes an angle theta in the direction of current, but makes an angle theta with the direction of current. Then current density will be current passing per unit area. Current is what? Di, and area dA. Now dA is going to be changed what? This component, delta A cos theta, delta A cos theta. Are you getting or not? We moved this object or surface at theta angle. That time it is perpendicular, but there is theta with this object, this surface area is having theta angle with current. Then this is the delta A, dA, and its component will be what? dA cos theta. So current passing per unit area will be what? Di current upon dA cos theta. That time when area is not normal to the current but making an angle theta, then we are getting current density Di upon dA cos theta. Clear? Solve this one for Di. Di equal to, when we cross multiply, we are getting this one. Now this can be written as J dot A, J dot delta dA, J dot dA. It means current density or dA, two vector quantities, dot product. Once we solve the dot product of two vectors, in the 11th standard we studied, if you are having two vectors and its dot product will be what? Magnitude of both vectors with angle of cosine, cos theta, AB cos theta. So J dA cos theta can be written as J dot dA, and this is what? Di. Now we are differentiating in, not differentiating, we are integrating in both sides. We are integrating both sides. Then integration of dx. What is the integration of dx is what? X. So where we are having variable I, so integration of di will be what? I, and this will be what? Integration of dA. So surface integration or area integration. What is this one? Area integration of current density. Observe, area integration of current density will be what? Current. Another definition of the current is what? Cross sectional area of a current density will be what? Current. So in the current density what we studied, I am just revising. This is the easy topic. Why we are taking this one? We started with the Ohm's law, and in Ohm's law we are having some physical quantities like voltage, current, resistance, current density, electric field intensity, conductivity, resistivity, and so on. So one by one we want to understand these all physical quantities, then we go further. So in the last class we studied electric current, and in this class we are studying what? Current density, or we can say electric current density. I am revising in 1 to 2 minutes what we are studying. Current density is what? Current passing per unit area. Its unit is what? Ampere per meter square in MKS, ampere per centimeter square will be in the CGS. It is a vector quantity. Observe, it is vector, so its direction is same as a current. Current direction will be electric field direction, and it is a positively charged direction. Clear? And its dimensional formula is this one. After this one, we also studied in the Ohm's law, current density is directly proportional to electric field intensity. Why? Because current density's direction is same as electric field direction. Clear? So we are getting this formula. Now average current density will be what? If we are having small area delta A and in which delta Q charges are flowing, or delta I current, delta Q charges flowing, it means current will be what? Delta I. Then delta I upon delta I ratio will be what? Average current density. Once we obtain the average current density, then current density at a point in a surface will be what? We will limited of average current density, then we are getting this one, we will put J average there and we solve, then we are getting di by dA. Di by dA is what? This is the current and this is what? Area. Clear? Then from this one we are getting, once we this area moved to theta angle, that time this area is perpendicular to current, or we can say current flowing is perpendicular to this area. But once we moved to theta degree like this one, then what we are getting? Then what we are getting? Current density will be current upon dA cos theta. What? It is moved to theta, so dA moved to theta, so its component will be, area component will be what? Delta A cos theta. So we will be used at the place of the area dA cos theta. Sorry, this is not delta, this is the dA. What is this one? dA cos theta. This is the dA cos theta. So this is the component of this area dA. So its component will be what? dA cos theta. Clear? Then we multiply, cross multiply, then we are getting di equal to this one, or J dA cos theta will be what? It is dot product of current density and cross sectional area. Clear? Once we integrate in both sides, then we are getting current. Its integration is current, and it is what? Cross sectional area integration of current density will be what? Current. We obtain the new definition of the current. Once we are having current density in terms of area, then integration of current density with cross sectional area will be what? Current. So that's all about this topic. Thank you so much.